The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome everyone to Coffee with Caleffi. I'm Kevin Freet, Director of Product Management and Technical Support here at Caleffi's North America headquarters in Milwaukee, sitting in for Bob Hot Rod Rohr today, who is doing some training up in New York State. And our topic today is temperature regulation for hydronic and domestic hot water systems, as you can see on the screen. And this will be centered around thermostatic mixing valves for the most part. We'll discuss how they work, the different types, how to select the right valve, how to apply them, etc. And today we have a very special guest. Claudio Ardizzoia is from our world headquarters in Fontanetto d'Agogna, which is near Milan, Italy. So, ciao Claudio, are you there?
Yeah, ciao Kevin. Hello to everybody. My really pleasure to participate at this webinar. Thanks, Kevin, again.
You're welcome. Or should I say buonasera? What time is it there? 7 o'clock?
It's 7 o'clock. Yes.
Okay, great. Well,
yes.
tell us about yourself, Claudio. Give us some background.
Yeah, thanks, Kevin, again. Actually, I'm a mechanical engineer, specialized in HVAC systems. And in past experience, I've worked as a design engineer and field management. And now I've been working for more than 20 years with Caleffi as a product marketing manager for development of new products and for certification worldwide. I'm actually an active member of some European committees for developing standards and a group for developing standard for plumbing systems and specializing in Legionella control, all those things. Yeah.
Okay, great, thanks. So Claudio is an expert in Legionella. We will touch on that a little bit. Also with us today, Mark Olson is in the background. He'll probably chime in as we go through the webinar today. And if you have any questions or comments, put those in the questions field, and Mark will answer those for us. All right, let's get started. So today we'll be heavily referring to a couple of our hydronics versions, number 7 and issue number 11, discuss mixing valves in various ways and applications. And a lot of the diagrams and the topics we cover today are coming directly out of those two. The whole collection, we're up to 18 issues now, is a great educational journal collection intended for hydronic professionals. It's a great resource for system design and component application and selection. So you can go online to our website and get all of these via PDF with a download, or you can sign up to receive hard copies of these as well. So you can register for that. All right, let's get started. Let's start at the top. What is a thermostatic mixing valve? My definition is a self-contained, thermostatically operated modulating three-way valve. It's a lot of words, but pretty basic. And primarily, there are 3 functions. Regulating hot water supply temperature to a distribution system is one. Also, they can be used to prevent scalding at a point of use fixture. That's a different type of valve. And they can be used to protect a boiler by maintaining minimum inlet temperature to prevent flue gas condensation. So at this point, Claudio, tell us just a little bit about the history before we get too far into it. How long has Caleffi been making mixing valves?
Yeah, actually, Caleffi, I would say, has presented the first thermostatic mixing valve, I would say, more than 20 years ago. And since then, I would say Caleffi added more and more versions of different mixing valves to suit the right application within the system. This is the difficult part. And Caleffi has also been working on the preparation and development of the standard for certification of the performance of the valve, and especially for every single application. This is so a lot of experience, I have to say, and a wide range of products now, I would say.
Okay, great, thanks. So the mixing valve reduces hot water temperature. Why don't we just heat the water to the temperature we need? Why do we have to heat it up to 130 or 140 or 150 and then mix it down? What is the reason we have to do that? And a couple of different good reasons for hydronics, actually. you can do that if you're using the type of heat source that does not require prevention against flue gas condensation. For example, an electric or a modulating condensing boiler or a heat pump. You can heat the water to the temperature you need, and you don't always need a mixing valve. However, Claudio is an expert in this. For plumbing applications, there are definitely health issues and safety issues in doing that, heating the water up to maybe 110 or 120. So talk to us a little bit about that, Claudio.
Yeah, well, everything has to be, how to say, related to the problem we have with Legionella mainly. And, you know, especially in Europe, Legionella problem actually has become more and more recognized. And we develop a lot of new specific regulation, and especially for the prevention of growth of bacteria, and mainly in cold and hot water system, I mean plumbing system. And thermal disinfection means the control of the temperature and control of the bacteria using the temperature. So, which is the simplest and the most effective way to control the Legionella, and with proven results. So, but the problem is that with the hot water, this means also that you have to protect the user from scalding using, especially high-performance anti-scald thermostatic mixing valve. So this is the reason why we are talking about thermostatic mixing valve and the relationship between the hot water and the anti-scald feature.
Okay, thank you. So let's get into the construction a little bit and talk about how they work. Here's a cutaway showing the hot inlet and cold inlet ports and the mixed outlet ports. So, Claudio, talk to us again. How does this valve work internally?
Well, the valve is a completely automatic valve. It has two inlet ports for hot water and cold water, and the water is then mixed and controlled with a thermostat immersed in, how to say, in the mixed water outlet. So it controls the temperature of the mixed water, balancing the two ports, hot and cold, for having and keeping constant the temperature of the outlet. And it is completely automatic because the thermostat reacts to the changes in temperature and the flow rate and pressure very quickly, and it modulates on the two ports, hot and cold.
Okay, so this little gold-colored element right here is the thermostat, and it pushes up and down on this cartridge to open and close the inlets. Do they close fully, given enough time? If that thermostat is hot or cold, will it close those ports completely?
Yeah, it closes completely depending on the type of mixing valve, how to say. So in case the mixing valve has an anti-scald feature, the answer is yes. So because you have to close the port to avoid any scalding or thermal shock for the user, so it closes completely and then reopens when the temperature drops. And one important thing for having the best reaction on the thermostat is to keep a certain delta T between the hot inlet temperature and the mixed water temperature. This gives, how to say, enough energy to the thermostat to react very quickly to the pressure and temperature changes, and mainly for the flow rate changes. So this is, how to say, a recommendation we can give for the correct operation of the valve.
Okay, thanks. Talk to us about the check valves. I know some of our models have integral check valves. Some are optional. The point of use valve requires check valves, but tell us a little more about those and why we need them.
Well, check valves are at the inlet. They have to be inserted in the hot and cold inlet, and are actually recommended for every mixing valve. And the main goal is for avoiding any cross flow, and especially in a large installation in big buildings, you can experience pressure imbalancing and recirculation loops. So the system is becoming more and more complicated, and it's good to have check valves at the inlet for avoiding any cross connection between the two networks. So,
okay.
and the check valves also, they are inserted in the tail pieces, and the tail pieces have different connections. So maybe threaded connections, press connection. So it's very easy, and they have one more feature that they can be replaced in case of leakage and so on very easily.
Okay. Sometimes we get the question, can I just put check valves in the valve that I have? And the answer is the tail pieces that come with one of our valves that's not integral, coming with check valves, you have to replace the tail piece. So it's a different tail piece. You can tell here by the cutaway that it looks a little different, but you can do that. You can order the check valve and the tail piece and cut out the old tail piece and replace it to add the check valves in the field. All right. Okay, here's a nice cutaway photo that shows us some more information. So, Claudio, what if the pressures are different? You mentioned in large applications where there might be a big system, you could have pressure differences in between the hot and the cold. What happens with that? I know our literature says there's a 2-to-1 maximum ratio.
Yeah, if the ratio between the hot and cold or vice versa is higher than 2-to-1, which is actually a high value, the valve reacts in an unstable way and with difficulty to the changes. So there's the behavior, unstable behavior means how to say that the temperature at the outlet is not it is with fluctuation, and the user can experience that. So what is recommended in this case is you have two options. Normally you can select a valve which is able to work with a higher ratio, sometimes up to 6-to-1 for high performance mixing valve, or obviously you have to control and reduce the system unbalancing at working with the pump system or the design of your network.
All right, and this note about pumping away from the mixing, obviously that's for hydronic applications, but tell us about, this is a really good picture that shows the internal cartridge. That material, it's non-metallic. We call that anti-scale material. What's that all about?
Yeah, the anti-scale material means a polymer material which has the surface with a particular property to avoid any scale to get stuck on the plastic, and thus I would say permitting the valve to work in a better way. Okay, good. It's part of the design.
So what if the flow after the valve has been installed is lower than the minimum rated? What happens?
Well, the minimum and the maximum, they have both to be checked and controlled by when selecting the valve. And the minimum is because if the valve maybe is oversized and the flow rate is below the minimum, there's an unstable behavior in terms of temperature at the mixed water, because the flow rate is not enough for the right contact with internal thermostat, and the thermostat is not able to react promptly to the changes. On the other side, if the flow rate is too high, so above the maximum, the velocity on the valve increases, and you can experience problems of noise or erosion as well. So it's good to select the valve, keeping the rules and the advice from the manufacturer to have the valve to work within the range between the minimum and the maximum. This is a very high recommendation and important recommendation.
Okay, thank you. Let's take a look at a recent ad for our thermostatic mixing valves. This shows our 521 on the left with press fittings and our larger commercial 5231 in the middle. Those are point of distribution valves, and the one on the right is a point of use, also referred to sometimes in our part of the country as an ASSE 1070 valve. for anti-scald. So it's a nice ad showing that. Let's take a look at some project pictures. We get some fantastic photos in from customers, and here's a really good one from Brian with Slavinsky Plumbing and Heating. Take a look at this. The heat source is on the right. The hot water comes up, out, goes through a Caleffi air and dirt separator, then down this pipe into the hot port of the mixing valve. On the other side is the cold inlet, and this is a model with the optional temperature gauge on the mixed outlet, which is a really popular option. And then you can see here we're piped to the suction side of the pump. That's accurate. That's the right way to do it. And that water gets delivered down to these three actuators near the bottom of the picture for some zoning that's obviously at a lower temperature than the zone over here, because the hot water coming through the discal dirt doesn't go through a mixing valve before it goes to this circulator and on out to this zone. So here is a two temperature zone. Really nice picture. Here's another one. There's a lot going on in this picture from Jamie up in Calgary. You can see the heat source is over here on the right. It's a really nice looking press fittings on this picture, but here's the primary loop going through a Caleffi hydraulic separator. Coming out of the secondary side, you can see this large pipe goes to a couple of circulators that pump that water directly out to some zones. And one of the legs comes down through a mixing valve. This is a commercial mixing valve, so this one is larger than the one we saw in the last picture. This valve right here serves these zone valves here. There's 5 shown, but I think there's actually 6 or 7. So this is definitely a larger flow range on this application. And you can also see another circulator here going down to some other loops. So we've got multiple temperatures in this application, and a couple of nice shots of our zone relays up here running the zone valves and the circulators. Great shot. Let's look at some schematics now. These come from the Hydronics journals I mentioned earlier, number 7. And here's a schematic showing 2 things. We have a boiler protection valve in this loop right here. This mixing valve is going to circulate this water. When this conventional boiler starts, the valve is cold and it will circulate 100% of the water through this loop to minimize the amount of time that this conventional boiler is seeing sustained flue gas condensation. So when this temperature right here gets up to 130, the valve will start to open and let water go out to the load. And by the time this temperature gets to 148, because we have an 18-degree throttling range on this boiler protection valve, then all the water will be going out to the load. At that point, we go through a mixing valve and drop the temperature down to 105 for this low temperature distribution system here. So 2 valves, 2 different functions working together in concert to protect the boiler and provide 105 degrees to the low temperature distribution system. There are a couple of pictures of our valves. This valve on the left is called our 280 series, and this is a commercial valve, the 5231. Now, we also have what's called a 281 thermal block, and this combines the circulator and the mixing valve to do the boiler protection in one housing, and that's a really popular product for us too. Here's a really good picture of some 281s. This came in from Bob. I think this project is up in northern Michigan, and those are 3 pellet boilers, and you can see here the 281 mixing stations. They have a nice jacket that comes with them to protect everything from condensation and to prevent heat transfer. Great shot. All right, now we can do both. This is a schematic showing an electronic motorized actuator and controller combination that's doing both protecting the boiler and providing water for the low temperature distribution system. There's a sensor here shown on the boiler inlet, and there's a controller integrated into this actuator. Also, we have a second sensor out here for the supply temperature. And in this particular diagram, there's an outdoor temperature sensor too, assuming that this controller can do reset. So in addition to protecting the boiler, we can deliver water out to this system and do outdoor reset if you have that type of electronic control valve. Here are a couple of examples of products on the market that you may have seen that do this, electronic mixing valves. All right, one more project picture. This one's fantastic. This was Bill up at Tip Top Plumbing. Actually, he won the last Caleffi Excellence contest and went to Italy on us. And you can see here he's got 5 different mixing valves. Each of these could be set to their own temperature. You could actually have 5 different temperatures. A couple of zone relays up here. This one with the red wires is controlling the zone valves you see over here. And a zone switching relay, you can see follow these flexible conduits down, are controlling these circulators. So that's a really great shot. All right, let's switch gears just a little bit again and look at some specialized thermostatic mixing valves. You can see here a 172 series. This is a manifold mixing station, and the mixing valve is right here. It's integrated into the brass casting with a circulator and a supply manifold, return manifold with flow meters, balancing valves, and gauges, and a little hydraulic separator. This H-shaped fitting right here at the bottom is a small hydraulic separator. And if you're going to leave that in, you need to have another pump out here in your system circulation. If you are going to use this circulator right here as your only pump, then you have to take that hydraulic separator out, or you won't get any flow from your heat source. This is also available in a 171 series, and the mixing valve has a motorized actuator on it, so you can do reset if you have a reset controller. That's a floating control actuator in the 171 series. We have a great picture here. Wow, that's almost a work of art. A couple of mixing stations. You can see the manifolds there with the manual mixing valves from Jamie up in Calgary, Alberta. Nice shot. Another specialized mixing valve. Our hydro mixer stations are shown here, the 166 and 167, and these are a pump combined with a mixing valve. In the case of the 166, it's a floating control electric actuator to do reset. The 167 series has a manual mixing valve, and those bolt directly to a Hydrolink manifold for a really compact and very efficient combination. Here's a diagram that basically shows you what's going on here. Let's say we have a boiler supply temperature of 160. It's coming through here. This is another small hydraulic separator. And this picture represents 3 different temperatures. Let's say we have a low temperature zone like an in-floor radiant system we want to do reset on. This actuator right here could be driven by the reset controller to deliver, for example, 80 to 110 degrees to that low temperature zone. We might have a 140 degree zone where maybe we have some panel radiators, and we could use the 167 series hydro mixer to set that at 140, and that would stay at 140. And maybe we have a couple of higher temperature zones, some thin tube radiators or something like that. In that case, we can pump directly out of the Hydrolink and deliver 160 degrees. This happens to be a 3+1, so a 4-zone Hydrolink. Really popular product. These are good for up to around 100,000 BTUs, so maybe up to a large residential system. And here's a great picture that really illustrates the compact size of this. They shoehorned this in between the window and the wall, and that's a pretty amazing looking shot there. So you can see the insulation jackets on there too, from Joe up in Massachusetts. Great picture. Let me get back to Claudio a little bit here. Now, Claudio, talk to us about sizing mixing valves. We have a graph here. This is one of our commercial size mixing valves, but this graph right here is a pressure versus GPM graph. So how does a person size the right valve?
Well, the right sizing of the valve is actually one of the best thing you can do in when properly sizing the valve for the installation. I mean, in plumbing, normally you have to consider that you have three goals, I would say, and which is the first is a good control and authority. So you have to give a certain ability to the valve to control the temperature. The valve has not to be oversized for avoiding any problem for the minimum flow rate. And obviously you have to respect the minimum and the maximum. So at the end, as a good advice, we would recommend to select the valve for having a delta P, a pressure loss between 10 and 20 psi, or more or less is on average for plumbing. For hydronic is a different approach because obviously you have to compensate the pressure loss with a pump in a closed circuit. So in this case, on average, we can recommend around 5 psi as a pressure loss. So this is the best advice we can give. And the selection of the valve, it's something that you can experience around selection. You can experience directly in the field after the installation if you have problems.
Okay, great, thanks. Let's look at a couple more schematics. I mentioned ASSE 1017 or point of distribution before. This is what that looks like. The mixing valve is located approximately there. And compared to a 1070 valve or a point of use valve on the right, those are located out at the fixtures. And so Claudio, would there ever be a time when we might need a 1017 valve and a 1070 valve in the same project?
Oh yeah, I mean this could be very, I would say, common sometimes. It depends on what you need. If you have different fixture, different application, but it's the perfect match because at the point of distribution, the installation of the mixing valve allows you to control the full system, the full network. And at the point of use, you can have a special valve able to control the user temperature for avoiding scalding. So actually, they can work in pair, and in different position in the system. And also, they have to fulfill special standards. So ASSE 1017 is especially for point of distribution with their own characteristics, and ASSE 1070 is the point of use with all the thermal shock and the anti-scald feature.
Okay, so if we had a facility that had like laundry and dishwashing where they might need temperatures greater than 120 and also had showers or tubs, then that would be an example where you'd need both.
Yeah,
right?
Exactly.
Okay, great. Here's a picture of one of our 521s installed on a solar hot water system. You can see how simple and easy that is. It's a nice shot of the expansion tank and the controller. And Claudio, we've been seeing some other valves in our market have these flexible connectors, and they maybe they're made more for a gas-fired water heater where you can go around the flue. So we're seeing some of those. We don't have one of those today, but what are the advantages of doing that? Are we looking at that at the factory?
Yeah, they are. You know, also here in Europe, the numbers of cylinders, of the water cylinders with the top connection, so connection of the pipes on the top of the cylinder, are becoming more and more popular. And so also in this case, because of the different manufacturer, the center distance between the pipes is not always the same. So a typical installation with a flexible hose is really, really helpful. So, and very simple. So it's good. It's good to have it.
Okay, good. Thanks. Here's a picture of an anti-scald valve, and I wanted you to talk a little bit about the special feature. The anti-scald valve, the 1070 valve, has a function that doesn't exist in the 1017 valve, this emergency shutdown. Tell us a little more about that.
Well, actually, the point of use valve is what is called high performance anti-scald valve. So the main feature is to have a thermal shut off, which means that in the event you have a failure, so a sudden decrease in the pressure of the incoming cold water, for instance, the valve has to react very quickly to close the hot port in such a way that you have no water coming out from the mix port. And this way, the user is always protected against scalding. On the other side, the valve has also the performance and the ability to close the cold port in case you have a failure of the hot, and the cold port for avoiding any thermal shock to the user generated by the cold water impact on the body. So this is one and the most important thing. And the second, another important thing of the valve is that valve is able to manage very low flow rate, down to 0.5 GPM, for instance, because now the old taps are equipped with flow limiter for water saving reasons. So in this case, the valve itself, the thermostatic mixing valve itself, is able also to manage this reduced flow rate. So both things.
Okay, thank you. Here's a great picture from Appropriate Designs. Is this what your bathroom looks like, Claudio? A nice bathroom like this?
Yeah, I wish it could.
Speaking of flow requirements, look at this. You could have just a person shaving at that sink, or you could have those showers running or that hot tub running, and the difference in flow rate is great. So we wanted to talk about this concept of high and low flow mixing valves. So here's the happy guy. If you want a high-low mixing valve, maybe he could install one for you. But here's a picture that came in where he actually has two sets. He's got a 521, a smaller valve, coupled, piped in parallel with a larger 5231 commercial valve. And you'll see there's a PRV located on the outlet of that large valve. And the way these work is the small valve will handle all the small flow, from zero consumption up to a few GPM for one or two fixtures. And when that draw gets up to a certain point, the pressure will drop on that common outlet pipe, and the PRV will open up and then allow flow through the big valve. So mechanically, that's how they work. And you can see he's built his own system here. Pretty interesting. And there are some companies out there that make these prepackaged and pre-piped, and of course we're looking at that as well. So, all right, shift gears just a little bit. Let's talk about recirculation. This is a picture that's in our Hydronics journal, number 11, and unfortunately this is a common mistake. To pipe the recirculation line back into the line as it's shown, where it goes to the mixing valve cold port or back to the tank, is typically going to be a problem because you have no control over where that water's going. You can get a loss of temperature in the recirculation loop, or you can get overheating in the recirculation loop. The point is, you have no control over that flow. One solution to give you control is to put in a couple of balancing valves, and this picture shows you where those should be located. And we're not going to get into too much detail right here because, well, for time is one, but we also have a 2011 Coffee with Caleffi that we did with a gentleman named Julius Belanco, and he goes into great detail on this. That's one of our most popular YouTube videos, so you can find that one. And it's also explained in detail in Hydronics number 11, how to do this, how to set it up and get it balanced. Essentially, you want to have just enough of your recirculation water going back into your water heater to make up the heat loss that's associated with your recirculation piping, so that it can balance out and have good stable control. So again, we're just going to move on, but there's a lot of information on this for anybody who needs it. Just let us know. Here's a picture of someone who did exactly that. This project was piped exactly like shown in Hydronics number 11. Steve Rogers out in Windsor, California did this. Great looking job. I wanted to zoom in here a little bit and show you what's going on. You can see the boiler providing hot water to this indirect water heater tank on the right. There's the supply and return, so heating up that water. The domestic hot water path is shown here with the mains coming down and follow the blue lines down and across, going over into the tank or going up to the mixing valves. In this case, they piped 2 mixing valves in parallel to give, to get extra capacity out of that. So the cold water is coming in the bottom, the hot water from the tank is coming in the top, and then going out to the hot fixtures. The really interesting part is here, what he did with the recirculation. The white line coming down here goes through this pump that has a stainless steel volute, as you can see there behind the line. Comes down and first goes through a check valve number 1. What this does is it prevents the cold water from running back through the recirc line when the pump is off and when there's a fixture open. So then we get to a T right here, and it goes into what I call BV1, or balancing valve number 1, shown right here, and that one will throttle that pump outlet pressure to reduce the pressure below the mains so that cold water can get into the cold inlet of the mixing valves. Okay, or the water goes down through balancing valve 2 right down here, and what that one does is it acts as an injection mixing valve, allowing just enough recirc water to go back to the tank to replace that heat that's dissipated in the recirculation circuit that I mentioned a few minutes ago. And lastly, this check valve number 2, shown right here, prevents that recirculated water from pumping fully and directly into the tank, which would then allow temperature creep of that mixed temperature during no demand. So this is a textbook piping job according to Hydronics number 11. You can also do recirculation and mainline mixing with an electronic mixing valve. So what we show here is mixing valve basically doing the same thing with a motorized actuator and a controller. And this has a sensor down here on the return temperature line. The controller will energize the recirculation circulator, and it also maintains mixed temperature right here. So it does a little more, and it can do more than just provide that mixed temperature control. And I wanted to get Claudio to talk about that a little more. We can do more. We can do thermal disinfection of the recirculation line with this valve. So since Claudio is an expert on Legionella control, here's a couple of valves that we have in Italy, in Europe, that we sell for this purpose. And Claudio, why don't you go ahead and explain a little more about what's going on here?
Yeah, actually, I would say the electronic mixing valves are becoming more and more popular, and they are normally installed as shown at the point of distribution. And obviously, they allow a very good control of the temperature in the network as a traditional thermostatic mixing valve. But the important thing, they can be programmed for thermal disinfection. They can keep recording of the actual temperature measured in the system. This is important for in case you have outbreaks of Legionella, you have to prove that you have recorded the right temperature. And they can be connected to a BMS. So from remote, you can drive and control the full network and the electronic mixing valve, and using, for instance, a backnet system. So important and grow.
Okay, great. We don't have this product here in the US yet, being the key word. Here's a photo, 2 photos of installed electronic mixing valves. The one on the left is a smaller one, threaded, and the one on the right is one of our larger flanged versions. So And you can see the controllers in the background too. You get a readout of the temperatures at all times. And as Claudio mentioned, they do data logging as well. Switch gears again one more time. Let's talk about balancing a little bit. In larger projects where you have multiple risers, you'll have a cold, a hot, and a recirc pipe. And in this simplified diagram, I mean, it's really simplified, one circulator handles all these risers, and you'll have varying pipe run distances in those risers. So to assure that you get good recirculation flow, you need to balance these lines. All right, we're almost done with the technical stuff here. Let's just cover a few of the common tech support questions that come in on mixing valves. We get this a lot. Can I mount it upside down? Yes, you can mount it any way you want. They're not sensitive. You can see in this picture here, it's upside down, and that's a very common way to mount those. My water isn't hot enough. What's going on? A couple things you can look at. Make sure your hot inlet is hot enough. Claudio spoke about that 20-degree delta between the mixed outlet and the hot inlet. You've got to have enough hot water to make that thermostat react properly. And check for dirt and debris and scaling. They, in hard water conditions, eventually you might see something like this. This valve we recently got back from the Northeast, and those green specks of sand in there are really hard, gritty deposits, and that cartridge was pretty much frozen by that material. What you can do is undo the union nuts, take the valve out, soak it in some CLR or lime away, that type of thing, and it'll break up that material, or replace the body. We sell these bodies by themselves without the fittings, and so if the valve it's way beyond cleaning, if it's really destroyed and too much calcium buildup, just replace the body.
Well, the main important thing we experience is especially in large installation, is not the correct installation as per the diagram. So as Kevin explained earlier, it was not the right positioning of the check valves, not the right selection of the valve with respect to the minimum flow rate. This is the main reason why the valve doesn't work as expected, how to say. This is mainly on plumbing. And the main problem we encounter, repeatable, as Mark said. And in hydronic, actually, problems are much more, they are less, how to say, less. So no particular problems in the hydronic, I would say. Just very simple, very simple. Maybe too high flow rate to manage, and the valve on the side, but that is the only one, to be honest. Well, I would say with a limited amount. I mean, up to between 30 and 50%, the valve, because of all the seals inside, are good also for glycol fluids. How to say, the valve can work without any problem. Above that limit, I would say is not recommended. Well, in a mix application, there isn't any other correct installation other than having the pump after the mixing. Otherwise, the system can't work. The valve is not working as a mixing. The valve is working as a diverter. So in a complete different application. Well, the most used is the chemical method with normally high percentages of chlorine or biocides. The only problem is that those chemicals have to be managed in a proper way. So because of the high chlorine content during the flushing, the system has to be cleaned and well flushed. Otherwise, all the components can be affected, and also the quality of the water can be affected. So it's simple. It can be good, but difficult to manage. And another common system, but it's quite costly, I would say, is the use of ultraviolet lamps in different applications. And that in this case, the flow rate and the size of the valve has to be obviously kept under control, and the cost of the system itself is very high. Well, normally the valve, obviously you measure the temperature and you see that changing, for instance, the pressure or the flow rate, the temperature changes too quickly. So there's a typical sign that the valve maybe is blocked inside by scale or some other problems. So the temperature doesn't remain at the outlet, doesn't remain stable. The temperature of the mixed water doesn't remain stable as well, so it has a lot of fluctuation, and especially when you have maybe gang shower application with direct use of the hot water, you can appreciate because you feel you are under the shower, for instance, and you feel that the temperature changes very quickly, so and it remains unstable, and this is due to the fact that maybe just one single tap or faucet is open and the flow rate is not enough. Well, actually, sometimes it's better to have a direct view of the installation of the system design. I mean, everything is to be combined. Also, if you have maybe a large system with recirculation, system has to be balanced. You have to respect the minimum flow rate, check valve in the right position. Yeah, there are some typical, how to say, guidelines to be followed, but the designer helps a lot in this case.
Okay, I think we have one question left, Kevin.
May I answer? From my side, I would say no, not at all. So it's a quick reaction, but absolutely no problem of water hammer.
Yeah, and any questions that we did not get time to answer, we have those, and we will reply. So we'll be in touch. Thanks, everybody, and we'll see you next month. Bye-bye.
And thank you from my side, and ciao to everybody.
Thank you, Claudio.